Okay, let's take a look at section 1.3.2, evaluate numerical expressions with rational numbers. So rational numbers, remember, are numbers that can be written as a fraction. So this includes fractions, like you see here. We can also have decimals because every, um, well, decimals that have a pattern or have a repeating pattern or have a terminating decimal, meaning they have an end. Those can also be written as fractions, and also whole numbers are also considered rational because they could be written as fractions. Okay, so we'll be reviewing some different rules with how you add, subtract, multiply, divide fractions and decimals. So evaluate the expression. So we're also going to be doing some order of operations where we're going to have to make sure that we do the multiplication first. Remember, that comes before subtraction. So multiplication with fractions is actually the easiest thing, I think. You just multiply the tops together and you multiply the bottoms together. So the next line here will go this way. That'll be 3 over 2 times 4 is 8. And we're still subtracting 1/4. Now, the tricky part is working with adding and subtracting fractions. So 1/4, we need to make it so that it also has the same denominator as 8. So we can do that by multiplying 4 by 2. And how this works is you have to multiply both top and bottom so that it stays equivalent. And then the next line will be, or the next to the right will be 3/8 still, but now we're subtracting 2/8 because that's what 2 over 2 gives us after we multiply 1 over 4. Now, when you subtract, really you're only subtracting the top numbers. You leave the denominator the same, right? Because it's we're subtracting, I always like to think of pizza. We're subtracting eighths of a pizza. So if you have three slices that were cut into eighths of a pizza, and you eat 2 of those slices, how many slices would you have? Well, you have 1/8. One of those slices that was an eighth. So there's our final result. All right, let's take a look at another level one. Here's we've got decimal numbers. So and let's not get too scared of these. But again, this is very similar to the last one. We're going to divide and then we'll subtract afterward. So let's get going on that one. So first, what is 0.8 divided by 8? Well, I think of first, I know that 8 divided by 8 is equal to 1. So 1 is going to be involved. It's just that the decimal is going to be moved over. So if we divide 0.8 into 8 parts, right? That's what that means. Dividing into 8 parts, it will be 0.1. So you keep that 0 point part. So 0.1, and then we still have to subtract 0.1. And actually, don't overthink this one. Whenever you subtract the same number from itself, that is nothing. That's 0. So 0 is the final result for that one. Taking a look at level 2. So notice that we've got a whole number in here, or an integer, and we also have division. So we have to do the division first, then we'll do the addition. So when I write this to the side, I'll just leave the 1 for now. Now, remember so division is not quite as easy as multiplying because there's like an extra step, but it's pretty easy. So when you're dividing fractions, you leave the first one and you multiply instead of divide, and you multiply by the reciprocal of the second number, of the second fraction. In this case, that's 1 over 2, so the reciprocal is 2 over 1. You just flip it. So dividing fractions is the same as multiplying by the reciprocal. And it's much easier to do, to think, because now remember what we said before. When you multiply, you just multiply the tops and the bottoms, the numerators and the denominators. So the 1 stays 1 plus, and That's going to be 6 on top. 3 times 2 is 6. And 4 times 1 is 4 on the bottom. And now we have to try to add these. So this is where I would do 2. Well, first off, I would reduce that 6 over 4. They both can be divided by, they can both be divided by 2. Divide by 2. Divide. So just like earlier when we multiplied the fraction by 2 over 2, we can divide the fraction by 2 over 2. So because that reduces it, and now we have 1, and it might be good to think of it as 1 over 1. Here, I might make the same kind of one. Plus now that's going to be 3 over 2. So notice that they do not have the same denominator yet. And this is easiest if we multiply both top and bottom. And I can see, well, okay, if I multiply 1 by 2, it'll give me the same denominator as the other fraction, because 1 times 2 is 2. And then therefore you also have to multiply the top by 2. Okay, so let's see, that'll be 2 over 2 now, 2 over 2, and we're still adding to 3 over 2. Just like before here, we'll work our way down now. The denominator stays, so it's like you have 2 halves of a pizza, and you have 3 halves of a pizza. If you add them together, you still have halves, but now we have a total of 5 halves. And we can leave the answer like that. I think this is write your answer as a fraction or as a whole or mixed number. So I believe it'll accept it. This is called an improper fraction when the numerator is bigger than the denominator. And I could give you a quick refresher on how to make it into a mixed number. So what you do is you ask yourself, how many times can the denominator go into the numerator? So how many times can 2 go into 5? And it can go in 2 full times, right? Because 2 times 2 is 4. So 2 full times. But 4 doesn't perfectly go into 5. There's 1 left over. So that 1 left over is the new numerator. And then we keep the same denominator of 2. So it's actually, that's the same as 2.5. So either of those would be acceptable. I think if you're typing this in iExcel, you'd type 2 space 1/2, or there might be a button for you to write mixed numbers. Another level 2 problem, we got some more fractions. This time we don't have to worry about dividing, so that's kind of nice. We'll just do, the first step will be the multiplication here, and we'll leave the 1/2 minus 4 alone for now. So 1/2 minus 4. And then, okay, so now when we multiply these, we multiply tops and then bottom. So 3 times 4 is 12. So it's going to be plus 12 over 4 times 5 is 20. So 12/20ths. Now I know those can be both divided by 2. And actually, they both can be divided by 4. So let's divide them by as big of a number as we can. If you don't think of that, that's okay. You can divide it multiple times until it's reduced. So technically all this other stuff would stay the same. So we still have 1 over 2 minus 1 over 4. But now it's plus 12 divided by 4 is 3. 20 divided by 4 is 5. Okay, so now we've got subtraction, we've got addition. We want to go from left to right, so we should do that subtraction first and then the addition. And you've got a couple different options here. So, well, we definitely need to have common denominators. And what we could do is we could do this one, get these denominators the same, then do this, or we could make sure that we could just change all the fractions so that all of these have a common denominator right away. And I think I like that idea. So it's maybe not super easy to always think about, but what number can all 3 of them go into? 2, 4, and 5. So it would be a bigger number. And you could pick a number that's you don't have to get the least common denominator. It is nice to do so, but it's not required. But the least common denominator here would be 20, because all of these, you can find a number that multiplies it to get 20. So like with 2, that's 10. With 4, that would be 5. And with 5, that would be 4. Okay, so here, I'm going to continue this over here. So now that's going to be 10 over 20 minus 5 over 20 plus 12 over 20, which I guess we didn't have to reduce that because we just made that back to a denominator of 20. Anyway, working from left to right, we would do the 10 minus 5 first, so that'd be 5 over 20. And then we'll add 12 to the 5. So that'll give us 17 over 20. So a lot of steps there. And 17 over 20 cannot be reduced. So that is our final answer for this one. Taking a look at level 3. Same kind of thing. The main thing that I see different here is some of our numbers are negative. Or actually, most of our numbers are negative. But we still should be doing multiplication before any of the other things. So right here, we'll multiply first. So I'll leave the negative 1/4 first. So remember, we're multiplying tops and then bottoms. So that's a negative, so you can think of this as a negative 3 times 3, which is negative 9. So we're adding, and that's a negative 9 over 4 times 5 is 20. And then we're subtracting a negative 1/2. Okay. So now we got all these additions and subtractions. So a little review. Well, first off, even before we do any of that, we need to get common denominators. And I think 20 is actually the common denominator again here. So we've already got 20 in the middle, but if I multiply this side by 5 over 5, and this by 10 over 10, we can then get them all to have the same denominator, so that'll be good. So that'll be negative 5 over 20 plus, that one doesn't change, negative 9 over 20 already had 20 as a denominator, and then minus negative 10 over 20. Okay. And we work from left to right. So this first one, negative, we're just focusing on adding the tops. So it's really the 20s, we shouldn't have to worry too much about the 20s. I know that the denominator will be 20 when I add these together. So it'll be something over 20 minus negative 10 over 20. So when you're adding negatives, it becomes a greater negative. There's a couple different ways to think about it. You can think about the rules like on a number line. Sometimes that's usually what I like to think about. So the first number, so the negative 5 is where we'd start. So let's just say right here is negative 5 on the number line, right? There's other tick marks on the number line. And if you remember, there's different rules. Adding means go right on the number line, right? So add, one way to think of adding, it means, hey, go right. And subtracting means go left. Okay, so those are good, except, and then a negative sign on the second number basically says do the opposite. So go the opposite direction. So a negative sign tells us do the opposite, or go the opposite direction, right? So that's what a negative sign does. So first, adding means go right, subtracting means go left, but a negative sign says, hey, actually go the opposite direction that you normally would. So in this case, we're starting with negative 5, and we're adding, so we think, okay, we must be going right. So we would be thinking we're going to go right on the number line. But we're adding -9. So if we were adding +9, I'd go right 9 on the number line. But we're adding -9, so we're going to do the opposite. We're going to go left. So from -5, left 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you could count what that becomes, and that should get us, remember, negatives get bigger as you go left, so this is -6, -7, and way over here will end up being -14. So long story short, -5 plus -9 is -14. Okay. And actually, I think it'll work out that we can use this exact same number line. So we're starting at -14 now, right? So because now we're thinking -14 minus -10. So start at -14. Minus means, hey, go left on the number line. So we were first thinking that we're going to go left, but since we're subtracting a -10, we're going to go the opposite direction, which is right. So going right, let me use a different color here. Going right 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's just to the right of -5, which actually is -4. So that's what you get when you take -14 minus -10 is -4. It's still out of 20. And actually, both of those can be divided by 4. So divide both of these by 4. And you get -1/5 as the reduced